The ability to add full custom dimensions through datapacks has finally been added to Minecraft in the 1.16 update. This has dramatically increased the power of datapacks, as we are now able to create things such as portals to fantastical dimensions like the Twilight Forest or the Aether, or even rockets that go to the moon or Mars. Previously, datapack creators had to use the roof of the Nether like in the Asphodel Meadows. Today, I will show you a system for implementing custom portals to custom dimensions that activate when a block is placed inside of a portal frame, similar to the Aether mod or the Nether. Today I'm going to be showing you how you could implement your own custom portals into Minecraft by using only datapacks in Minecraft 1.16. I'm currently using Minecraft 1.16 pre-release 2, but it should work for any version. So as you can see here, I basically recreated the Aether portal. So I have a glowstone portal the size of a normal nether portal, and now if I place a water bucket inside, it will summon the water looking Aether portal, and if I step inside of it, it transports me to another dimension. And if I hit the F3 menu here, you can see that in the top left corner it says that the dimension is test dimensions Aether test, and as you can see, it's obviously a custom dimension because it has a bunch of pink wool to replace all of the stone, and it's a bunch of floating islands and not the normal world. So I'll show you how you can create this kind of custom dimension in the end of the video, but today I'll mostly be focusing on how this pack works to create your own custom portals. So normally for a tutorial I would go through everything and create it with you guys just to show how everything works and the whole process, but since this has so many commands in it compared to my normal tutorial, I'm just going to be going through what I already created and show you how to basically customize it for yourself. But the first thing I'm going to do is go through a very detailed explanation of how the entire thing works by going through all of the function files, but I have a feeling a lot of you are going to want to skip that part, so make sure to go to this timestamp if you just want to be able to download and customize it for yourself. I'll show you how to tweak the data pack to use your own portal frame blocks and portal blocks, how to of course use your own custom dimension, and how to change up the sounds and particles that display. And finally, I'm going to go over how to create your very own dimensions with the online generator, but keep in mind that the way to create custom dimensions has a very high chance of changing in the future. So there are a few main parts for how this works. The first part is raycasting to detect where I place the water block every time I place down a bucket of water. And then there is detecting based on that water block if there is a frame around that water block position. And then there is the part of marking the portal. And then there's detecting if an entity that can be teleported walks into the portal and then actually teleporting it to the dimension. So now I'll go through all of the actual MC function files that I created. So to start off, we have the load function, of course. If you don't know how to create your basic data pack, then make sure you go check out my how to create a data pack video. But there are just a couple telraw commands to show that the data pack has loaded. And then I simply add one scoreboard objective for Minecraft used Minecraft.waterbucket just to detect when I place down a water bucket. Then in the looping MC function, what I have is the raycast, which will run if the water has been placed. So if it detects that the score for portal 1, which is the name of the scoreboard for detecting the water, if that increases by 1, then it will go to the player's exact position and rotation positioned at their eye level, and then it will run the function of casting. So it's tf portals, which is my datapack namespace, then portal1, which is the folder with all the files for my first portal, and then cast. So in cast, this is running at the position of the player, at their eye line, at their rotation. So first I summon the area effect cloud at their eye level, and then I match the area effect cloud's rotation to the player's rotation so that it is basically looking exactly where the player is looking as they place the water, so that when it teleports forward, it will intersect with the water block that was placed. And this area effect cloud is basically just being used as a marker. And so it has a duration of 120 so that I don't have to manually kill it off, it'll kill itself. And then it has the tag of P1 cloud so that I could detect it later. And of course it resets the scoreboard so that it doesn't keep summoning like an infinite amount of area effect clouds. And it also ensures that I'll be able to detect future blocks of water that are placed. So now that the area effect cloud with the tag of P1 cloud has been summoned in the loop MC function, then I run the cloud function on the area effect cloud. So I'm executing as the area effect cloud and at its position, and I'm running the cloud function. Now here it looks like a lot, but really all you have to focus on is just one section because it's a bunch of repeating stuff. So just focus on this section here. So every tick, this section is going to be running 10 times. So it executes at the position of the area effect cloud as long as I haven't canceled the detection yet. I'll show you what that means later. Then it will teleport by 1/10 of a block forwards. And then each time that it teleports forward, it's trying to detect if it intersects with that water block that you just placed, because the whole purpose of raycasting is to get the position of the water block that you just placed. So if it does detect that there's water, then it runs 3 checks. It runs if either there's glowstone directly below it. So let's say you place the water at the low level of what would be a portal. Then it wants to detect if there's glowstone directly below it, or it'll run checks for if it's at the center, then it'll run 2 blocks below it. And then if you place it at the top, then it has to be able to detect if there's glowstone 3 blocks below it. And I just split it into 3 sections for the bottom, the middle, and the top, just to reduce the amount of checks I have to do, so I don't have to run an unnecessary amount of checks. And the reason that I did 1/10 of a block instead of just using 1 block forwards is because it increases the accuracy. So instead of doing 1 block forward every tick, I do 1/10 of a block forward 10 times during the tick. And the reason I can't just do one section of this is because it would move too slowly if I just did one section of moving 1/10 of a block per tick. So I just duplicated it because it's able to run the calculations multiple times per tick. And then after the cloud reaches the water with the potential frame around it, then it's going to run the full detection commands, which are low check, mid check, and top check. So I'll just go through low check right now just because they're basically all the same. It just runs the same commands except for different positions. So the first thing that it starts with is it runs at the position of the area effect cloud when it detects that there is a water block with a potential frame around it by detecting that the piece of glowstone was underneath that water block. So it executes unless there's already an item frame there. It summons an item frame which is invisible with the tag of portal align, and the only reason I have to summon the item frame is to make sure that it's centered on the block, because when I summon an area effect cloud, depending on where I was looking on the block, it'll still detect a piece of water, but the area effect cloud will be in a different spot each time. So if I place it while the water's here, or if I place it while my rotation is on this side, it'll be in a different spot. So I just use the item frame to make sure that I have a consistent center point on the block to reference when I want to summon the armor stand that will mark the position of the portal. And speaking of marking the position of the portal, I have to detect the structure of the portal frame, and as I wrote here, I'm trying to detect there's 4 positions it could be. After I know that it's in the bottom of the portal, for example, I know it could either be on the left side z-axis, right side z-axis, left side x-axis, or right side or left side x-axis. This is just a detection command which is trying to detect the shape of a frame around the portal block, and there's 4 possible positions, which is why I have to have 4 separate execute commands. And it might look complicated, but it's just a bunch of repeating if block statements just to check if there are blocks in the shape of the portal. And so if there are blocks in that specific shape, then it will run at the position of the item frame that was used to align and make a consistent position. And then it will position itself to wherever it has to be. So for example, if it's a left side Z, then it's going to go, okay, I'm positioned here. So what I have to do is move half a block to the right on the z-axis, and then 1 block up on the z-axis, and summon the marker armor stand in the center. And the reason I want to summon it in the center is so from now on, all I have to do is run on the position of the marking armor stand instead of having to run the detection again to see which type of armor stand it is. And of course, if you have more questions, just go into the description and ask like which part you want more clarification on, because I can't go into detail for every single command, but I'm trying to give like an overview of how it works. So now I'm summoning the armor stand here, and this armor stand is invisible because I don't want to see the actual armor stand, and it has the custom item nether brick on top of it, which has the custom model data. If you don't know how to do custom model data, then go check out my video on that. I show you how to make custom items and custom models for any item in the game. And then I make sure it's small just because it's easier to run commands, and it's more it makes more visual sense when it's a small armor stand. And I also give it the tags of portal Z, portal 1, and cloud active. So I'll show you what those do later. Portal 1 is basically just marking, okay, there's a portal here, and make sure you run your commands for the portal on this armor stand. So there are two commands for portal Z for the two positions that could be existing on the Z axis or the two positions for the X axis. And the reason for that is when I go over here, what I'm doing is I'm trying to make sure that that no matter what, even if it's an X-axis portal or a Z-axis portal, I want the armor stand to be facing perpendicular to the portal so that I know for my future commands that the portal's position, the portal frame position relative to the position and rotation of the marking center armor stand is consistent. So this stuff here is just to remove the water. This is just removing the alignment frame because I don't need it anymore. I already used it. And then this is just tagging the detection cloud to make sure that I cancel any more detections that haven't finished inside of the rest of this chain of commands. And then it also makes sure that once the tick is over, it does kill the cloud. And then after this, it removes the cloud active tag because cloud active is basically signaling that the portal detection has succeeded, but the cloud is still running its detection commands. So I want to finish everything such as the play sound and the particle commands and removing the water. I want to run all of that just once as soon as the detection is completed and succeeds, and then I don't want to keep spamming play sound and particle. So then at the end, I remove cloud active. So all of these only run once as soon as it's detected. So now that it has detected, the marker armor stand in the center exists. So I could actually show you that here. Okay, so what I went ahead and did is I removed my resource pack, which shows the water for the portal. So now you can see the invisible armor stand in the center with the nether brick on top. And ignore the other armor stands for now. I'll show you what they are later. But as you can see, that center armor stand is marking the position of the portal. And if I move back, you can see that that armor stand with another brick on top stays there, but the other ones disappear. I'll show you why. So now that it has spawned, we have something to mark the position of the portal. So let's go back to loop. And if you remember, that marker armor stand in the center of the portal had the tag of portal 1. And so I want to run at the position of all portal 1s. I want to run this function, which is just called portal 1. So now we're in the portal 1 function. So what this is it's a command that runs at all armor stands which are signaling that there is a portal at their position. So first of all, to run the detection for if the frame is destroyed, because I want to make sure that if the frame is destroyed, then it destroys the armor stand. So the way I do that is at the beginning of the tick, I remove the tag called stable. And then after that, I run a detection command, which detects for the exact frame position around it. And that's the reason I wanted to make sure that the armor stand was perpendicular and perfectly centered inside of the portal, because now all I have to do is run the single detection command from the position of the armor stand to ensure that the frame is still intact. And then if the frame is still intact, then it runs the tagging command, which adds the tag stable back to it. And if it doesn't add the tag of stable back to it, then it will run the function for destroy. And inside of destroy, it basically just kills the armor stand. It tags it as dead so that it doesn't run anything else inside of the portal 1 function. And it kills all of the extra armor stands, which I'll show you later. And then it also plays the sound for breaking it. So now I'll show you what those extra armor stands were. So what this is doing is it's running if the center marking armor stand has not been marked as unstable or dead yet. And it is trying to detect any entity that walks nearby that is of the type which is in the entity tag of TF portals P1 can teleport. And so what that is basically inside of the data pack itself. If you haven't messed with this before, it's an entity tag, which basically puts entities into a group. So if I go here and I go to tags and entity types, you'll see P1 can TP. And so these are all types that are allowed to teleport. Right now I just have players because when I was trying to do items, it was kind of buggy. But if you're able to get items working, all you have to do, you don't have to change anything else in the code other than adding other types. So let's say you want to add items, you just do Minecraft item or something like that. But anyway, I'm not going to mess with that. I'm just going to keep it players for now because I wasn't able to get items working perfectly. if it detects one of those teleportable entities that are in that list and it's in a 3-block radius, unless the extra armor stand has already been summoned, then it will summon the extra armor stand in a 2x3 grid. And the reason for that is it'll increase the accuracy of the detection. So if I create a portal and then I go into spectator mode, you'll see those extra armor stands. So notice that armor stand in the top right. See that one? If I back away, it'll disappear. And those armor stands only appear when you get near because I increase the accuracy of detecting. What I could do is say, oh, if a player walks into a 3-block radius of that center armor stand, then teleport them away. And that would work if I move closer, but if that would also mean that I would teleport if I moved at it from the side. So in order to increase the accuracy of detecting the player within a rectangular area instead of a spherical area, I just basically made a grid of smaller, a 2x3 grid of smaller spheres to detect the player. So now that we get to the teleport command, what this is basically doing is it's detecting if a teleportable entity is within 0.8 blocks of those extra armor stands that are creating the detection system, then it will teleport them into the opposite dimension. So if they're in the overworld, it detects with the predicate and it teleports them to the custom world, and if they're in the custom world, it teleports them to the overworld. And the way it does that is just by running the command either in the overworld or in my custom dimension either test. And then if there's nothing nearby, so if there's no teleportable entity within a 3-block radius, then what it does is it just kills those extra armor stands, because armor stands cause lag, so I'm trying to kill everything that doesn't have to exist. And then also this last thing here is when the player is teleported through, they're given the tag of teleported, because I don't want them to teleport through and then, oh, you're in the portal, now teleport back. Oh, now you're in the other portal, teleport back, and they would just ping pong between both of them. So what I do is I give them a tag of teleport, which means they're not allowed to teleport until they leave the portal and their tag is removed with this command, and then they re-enter it. So here's the actual teleport command. So what happens here is first it teleports the player to the same coordinates. And the way that this works is it's running the teleport command in the opposite dimension but at the same coordinates. So if you're at 0, 0 in the overworld, then it runs a teleport command at 0, 0 in the other dimension. So teleporting you to the same spot will teleport you to the same coordinates, so to 0, 0, but in the corresponding or opposite dimension. And then it'll add that tag that I was talking about to prevent ping-ponging between the dimensions. And then now this is running a command which executes at any portal within a 20-block radius of where you appeared in the corresponding dimension, and it will try to teleport you to anything that already exists. But if a portal does not exist, it has to create its own portal. So it just runs 2 fill commands, one for the glowstone and one to hollow it out to fill it with air. And then it summons the armor stand manually back into the center of that portal. So these 2 commands here are just to ensure that the rotation of the new portal that was forced into existence matches the rotation of the portal that was in wherever you came from. And then this just teleports a player back to that portal that was just created. And then it just plays some sounds. So that's basically everything about how it works. I know it was a lot, but if you have any other questions, make sure you go into the comment section below and ask whatever questions you want. I'll try to answer every single question because I know this is a lot, but I really want you guys to be able to use this. So here's how to use this data pack to add your own custom portals to your own custom dimension. So I'm just going to go through everything that you would have to change in order to fully customize it. So first, go to the data pack that will be in the description below. So it's just going to be a folder like this. And you have to go in here, and there are 2 things that you have to change. So first, go into Data, Minecraft Dimension, and Test Dimensions, and then drag your own custom dimension into here. I'll show you how to make that at the very end of this video, but after you get the JSON file for that, you want to drag it into Test Dimensions. Then after that, the second thing you want to change is the predicate. So go, instead of Minecraft, go to tf_portals, and then go over to predicates. And then in overworld, you could keep it exactly how it is, but for in either test, change it to whatever your dimension is going to be. So let's say you're calling your dimension my custom dimension, then you do in my custom dimension.json. Then open it up, and then the only thing you have to change in here is test dimensions, and change this to whatever your JSON file for the custom dimension file is that you just added in. So if you called it mycustomdimension.json, change this to mycustomdimension. Okay, so now let's get to the functions. So in order to change the portal block that you want to use, so I used a water bucket as the portal block. What you have to do is change this scoreboard in load.mc function, change water bucket to whatever block you want to use for the portal. So if you're going to be using andesite or something, then change water bucket to andesite because you're detecting the used and you want to raycast only when you happen to use your portal block. Then you also have to detect for the actual block being placed, and that is inside of the cloud function. So all you have to do is do Control F or Command F, and then just search for water and replace it with whatever you want it to be. So if you're doing andesite, then just replace all, and that's all you have to do. But I'm just going to keep it how it was. And now if you want to change the portal frame block, so I used glowstone. If you want to change it, the first place you have to change it is in cloud. It's basically the same thing. You're detecting water and then you're detecting glowstone. So you want to do the same thing. Detect for the glowstone and replace the glowstone with whatever you want it to be. So if you want your frame to be made out of bedrock or something for some reason, then you just want to replace all of the glowstone with bedrock. And so you have to do that in the cloud MC function, and you also have to do that inside of low check, mid check, and top check. So it says glowstone here, then just replace all the glowstone with bedrock. So make sure you use Control F, don't do it manually, that's a pain in the butt. And another thing you have to change is in the teleport command, where it automatically creates a portal if there isn't one already. Then you have to change this glowstone. That's the only one that should be in existence in this file. So you have to change that to bedrock or whatever you want for your frame block. And then you also want to change it in portal 1 because you're detecting the integrity of the portal, and if it gets destroyed you have to be able to detect it. So do the same glowstone replacement in this portal 1 MC function file. And that should be it for changing the portal frame. But if you want to change the shape of the portal and you don't want to use a default portal, then you'll have to change the detection and the shape for everything, and that will have to be changed inside of cloud because you might not be detecting directly underneath. And you also would have to change in low, top, and mid check. You might not even use low, top, and mid check. You would have to create your own checks. But the only thing you would have to change is this execute if, like this huge execute if block, but all the other commands, so everything above and below those execute ifs should be the same. You should be able to keep the same summon command if you're changing the shape of the frame. And the only other thing you would probably have to change if you're changing the shape of the frame is inside of portal 1 where you summon all of these extra armor stands for better detection. Then you would probably have to change the shape that they summon into. And of course, to change the actual dimension which you're being sent to, you want to make sure to go to portal 1 and go over to the teleport section, and where it's overworld to custom and custom to overworld, what you want to do is replace in test dimensions Aether test. You want to change Aether test to the name of your JSON file, so it would be like my custom dimension. And then also the predicate, remember you changed the name of the predicate file earlier, so instead of in Aether test, it would be in my custom dimension or whatever you named it. And now in order to set the model, so for example I used a portal looking flowy water portal thing, you have to change the item on the armor stand's head, and so that would be inside of low check, mid check, and top check where you summon the center portal 1 armor stand. You would have to change the armor item that is on its head, so I used a nether brick with custom model data, and you would have to change this to whatever your custom model is. If you don't know how to create that, make sure you check out my blockbench video. And you would also have to change the summon command that exists in teleport that forces a portal into existence if there isn't already one. It's basically the same command in teleport and low, mid, top check, but you just have to make sure that you replace it with your own model. And finally, custom sounds and particles. The places to change that is inside of low, mid, and top check. There are some particle and play sound commands right here. You would just replace these play sound commands and these particle commands with whatever particles and sounds that you want. You would want to keep everything here, like the execute at command. And you would also change the particles in the destroy MC function block. So I just have some sounds here, but you could also add more particles and more sounds if you want. And the last place where you would customize the sounds and stuff like that is in the teleport MC function. You could change the sounds that are played during the teleport function. So that is everything about how to customize this data pack to make it work for your own custom portal. Now let's get into how to create your own custom dimension. So before I get into this, make sure you keep in mind that the way that you create custom dimensions has a high chance of changing in the future. And look at the pinned comment down below just to check if there have been any important changes that you should know about. So this is the current way to do it in 1.16 pre-release 2 and pre-release 3, which just came out today, and I just had to fix a bunch of stuff. But I'll show you how to actually create it. So go to this link, which will be in the description, miso.github.io/worldgen. So now you'll see it comes with a default world. It's the overworld, nether, and the end. And this is for generating a world, but we want to generate just a custom dimension. So what you want to do is hit remove dimension for all of these, and then just add some random dimension. So call it whatever you want because it doesn't matter. And then just hit add dimension. So now you'll notice there are a few settings here, and it does get a lot more complicated, but you could choose how in depth you want to go. So first of all, choose your world default or super flat. Don't do debug world. I don't really know what it's for. So just hit default, and because that's probably what you're going to do. And then default C, just hit whatever you want. And then, so the biome source. So there's a few different ones here. Multi-noise is my favorite one, or the one that I would use, but I'll show you all of them. So there's fixed, which sets it to just one biome for the entire place, which is kind of lame. And then you have checkerboard, where you could input whatever biomes you want here, but you can't really configure them. So it'll just lay out all of these biomes into a checkerboard pattern. And then there's the end, which I wouldn't use. And then vanilla layered is basically just the vanilla biome layout. And the large biomes you could change, but other than that, there's not much. So then you go to multi-noise, and you have more control over what you want to do. So just set the C to whatever. And then the biomes preset, you could just add more biomes. So let's say I'm going to do a shattered savanna plateau. And then you could change the altitude, weirdness, offset temperature, and humidity. And as it says here, you're just trying to set it to some random combination. Or it doesn't have to be random, but it's going to pair similar biomes together. So for example, if you have hot biomes, then you want to put the temperature close to each other as opposed to the cold biomes, so that you don't have a bunch of hot and cold mixed together where it doesn't make sense. But if you want that, then you could just make the temperatures like all the same, just keep it how it is. And then after that, we have generator settings here, which you could choose preset ones, which is a lot simpler than changing the actual generator settings. But so there's overworld, nether, and end. Those are pretty obvious. And then amplified is the amplified tall terrain. And then caves means that it generates kind of similar to how the nether generates with the roof on top, except it generates your biome, so it's not the actual nether. And then we have floating islands, where there's no bedrock top and no bedrock bottom, and the islands are all like a bit separated. But if you want to make it have custom generator settings, what you want to do is click on generator settings here, and then there's a few more stuff you could change. You could set the bedrock roof and floor position, and if you want it to not exist, you could set it out of bounds. So set it outside of the range from 0 to 255. So if I set it to -10 for both, then it will have no top and no bottom. And then sea level 63, you could set the sea level to whatever you want. Default block, you could replace all the stone like I did with the pink wool. You could replace all stone with something, or all water with something. And then it gets even more complicated here in noise options, and I don't even know what all of this does. If you want to know more in depth for what people know so far, you could go to minecraft.gamepedia.com/custom, and it's about the world generation, but not all of it's actually filled in yet. But I'll go through what I know. So density factor, set this to 0 if you want islands. That's what I did for mine. And then amplified, that's self-explanatory. And then size horizontal and vertical is about the smoothness of the terrain and like the size of the terrain. So for example, vertical, if you set this to 4, then what happens is you get like cliffs instead of like islands. Like, so even if you set floating islands and you set this to 4, you're gonna have more cliffs than actual like balls of islands kind of. And then height basically sets the height of the terrain. If you set it to 256, it's going to go like all the way to the top and just be like this flat thing. I don't know, it's kind of weird. So set it lower. And then X, Z, and Y scale. This is for like the amount of horizontal and vertical detail according to the Gamepedia. So you want to set the Y to like a higher number, I think, if you want more like vertical detail or something like that. I wasn't able to notice it too much, but that's like the only one I messed with, and I don't know what any of these do. And then structures, you could add it through here, but so far there isn't a drop down menu like there is with the biome, so I don't do it through here. I'll show you what to do for that. And then dimension options, for some reason the default doesn't work, and like the world doesn't load when I customize these, so just set it to overworld for now. So now what you want to do is go up to the top and hit copy and go into the data pack. So I'm in the world, so data packs, into my data pack, data, Minecraft dimension, and then go into test dimensions if you want, and then just duplicate this. So what we did was we created a world, not a dimension, so we have to delete everything for the world and just leave the dimension. So go to line 6 and line 2, delete everything there in between generator and the first bracket, and then go to the very end and delete the 2 second to last brackets, so the 2 before the last bracket. Just delete that, and then you'll have to get the structures. So I have a different file here inside of the dimension folder. There's downloaded world settings. This is, I think, one of the game devs tweeted it out. So go into the structures area here. So you'll notice structures, and then there is a single bracket. So highlight everything after that single bracket. So line 67, Minecraft jungle pyramid, and get all of the structures all the way to the ocean ruin, and then go to the last bracket that's from ocean ruin, and then copy that and paste it into structures. And to make sure that you have the proper amount of brackets, just do Control or Command F and search for left brackets, say it's 32, and then right brackets also 32. As you can see down in the bottom, you just want to make sure that the amount of brackets you have is equal, just to make sure you copy pasted everything correctly. So now save that, and let me rename it to World 2. So once you're in the game, do /execute in, and then if it worked properly, your dimension will show up in the autofill. So just click on it and then do run TP at S and then to your coordinates, and it will teleport you to the matching coordinates in your custom world. So I just had a shattered savanna plateau. Yep, and here we go. So as you notice, let's fly around here. So I didn't actually set any like custom things really at all. I just set it to Savannah Plateau. If you want to configure your world after you created it already, like you dragged it into your world and you don't want to have to copy paste and edit everything over and over again, just leave. So open up your dimension file, and then you could just change it from here. So for example, density factor, let me set this to 0 to get floating islands. Let's replace water with air, and stone with bedrock. So now that I set that, what you want to do is go into the world folder and delete the dimension that I already generated. So test dimensions, and then it was called world 2. So now if we go back into the game, you should see that it generates into a different world, a different terrain. So let's see. And now as you can see, I have floating islands, and they're made of bedrock with no water everywhere. So that's how you create your own custom dimensions in Minecraft 1.16, and how to create your own custom portals for those dimensions. Stay tuned for future videos. I might release other videos relating to custom dimensions, but not sure yet exactly what. But the next video that's coming out is going to be the custom mobs video. So stay tuned for that, and I'll see you guys later.